is formed by a concave mirror using ray diagram. Okay, so for this one, we have 6 cases. It depends on the position of the object in front of a concave mirror. So let us first draw our principal axis. And then draw our concave mirror. Locate our vertex, our center, and our focus. Again, the focus should be at the middle, directly at the middle of the center and the vertex. Okay. In case number 1, as you have noticed that the object is at infinity, it means that the object is very, very, very far away from the mirror. In this case, we will not be using the 3 light rays that I have told you. Instead, we will be just considering parallel light rays from a distant source. Suppose we are going to draw here light rays from the source. Okay, parallel lines means they are parallel to the principal axis. Okay, so these parallel light rays, when they hit a concave mirror, they will be reflected and they will all be passing through the principal focus. So each line here, each light ray here will be passing through the principal focus. And remember, the point of intersection of light ray is the formation or location of image. Okay, so as you can see, all the light rays actually intersect at one point, which is the principal focus. Now, let us describe the image using the LOST method. Okay, L for location, O for orientation, S for size, and T for type. Location. So very easy, it is located at F or located at the focus. Next, orientation. So it is just a dot. It means it is very, very small. So definitely, we cannot determine by just looking at it the orientation, whether it is upright or inverted. But there is a way for us to determine. Look at these light rays. Okay, so these light rays will help us to determine the orientation. Look at this light ray from the top of the mirror. So when it hit the mirror, it reflected downward. While the light ray from the bottom, when hit the mirror, it reflected upward. It means that the light ray from the top of the mirror goes down and the light ray from the bottom goes up. So it means an inverted image. Okay? So therefore, the orientation of image becomes inverted. Definitely, what will be the size? Definitely, it is just a dot. It would be smaller than the object. And the type, since it formed in front of the mirror, it should be a real image. Okay, in case number 1, the object is at very, very far distance from the mirror or at infinity. The image form will be located at the focus, inverted, smaller, and real. Okay, let us now proceed to case number 2. This time, the object is beyond C, or it means it is behind the center of the curvature. So let us first draw the principal axis. Okay, draw the mirror, locate the vertex, the center, and the focus again, which is directly at the middle of the vertex and the center. So according to case number 2, the object is beyond or behind C. So let us draw our object here. Suppose this arrow here is our object. Okay. Now we can do the 3 light rays. The first light ray is a ray parallel to the principal axis. Okay. From the top of the object, we will draw a parallel line. And then, when it hit the mirror, it will be reflected passing through the focus. Next, the next light ray is a ray passing through the center of the curvature and reflected on the same direction. Next, a ray passing through the principal focus and will be reflected parallel to the principal axis. As you can see, the three light rays intersect at this point. So therefore, the image will be there. Since the intersection here is at the tip of the arrow, therefore, here, this also represents the tip of our arrow. So we can draw our arrow as this way. Okay, so this red arrow represents our image. So let us describe the image form using lost method. Okay, location. As you can see, the image form between the center and the focus. So it is between C and F. Orientation, as you can see, this one is upright, this one is inverted. So definitely the image becomes inverted. And then the size, look at the size. The image is smaller compared to the object, so it means smaller. And the type, since again it forms in front of the mirror, it would be a real image. So again, case 2, object beyond the center, the image form will be between the center and the focus, inverted, smaller, and real image. Okay, let us now proceed to the at this let us now proceed to case number 3. Object at the center or object at C. Again, let us start by drawing our principal axis and then our mirror. Locate the vertex, the center, and the focus. Again, the focus should be directly in between the center and the vertex. Let us draw the object here directly at the center of the curvature. Okay, let us now draw the light rays. The first light ray is a ray parallel to the principal axis and then will be reflecting passing through the principal focus. Next, a ray passing through the center. So the second light ray is not applicable since the object is directly at the center. So we proceed with the third light ray, which is a ray passing through the focus. Okay, a ray passing through the focus and reflected parallel to the principal axis. Okay, so as you can see, the light ray intersect at this point. So therefore, this is our image. So the tip of the object is the intersection of light rays. Therefore, the tip of the image here is also the intersection. So this is the arrowhead of our image, and this is the body. Okay, so let us now describe the image form using lost. Location. As you can see, it also forms directly at the center. So located at C. Orientation, it is obviously inverted. The size, as you can see, they have the same size. So same size. And the type, since it forms in front of the mirror, will have real image. Okay, just to summarize, the object form or the image form when the object is at the center is located at the center, inverted, same size, and real. Okay, let us now proceed to case number 4. This time, the object is between the center and the focus. Again, let us start by drawing our principal axis and then our mirror. Locate the vertex, the center, and the focus. Remember that the focus is directly at the middle of the vertex and the center. And according to case number 4, the object is between the center and the focus. So let us draw our object here, somewhere in between the center and the focus. And let us do the light rays. The first light ray is a ray parallel to the principal axis. And then it will be reflecting, passing through the principal focus. Okay. And then the second light ray is a ray passing through the center of the curvature. And reflected in the same direction. And the third light ray is a ray passing through the focus. And reflected parallel to the principal axis. Okay, so as you can see, the intersection occurred here. So therefore, there is the image. So let us draw the image. Okay. So let us describe using LOST method. L for the location. As you can see, it formed behind C or beyond C. So located beyond C. Orientation, it is inverted. Size, definitely it is bigger. And type, since again it formed in front of the mirror, definitely it is a real image. So, if the object is in between the center and the focus, our image is beyond the center, inverted, bigger, and real. Okay, let us now proceed to case number 3. Object at the... Okay, let us now... Okay, let us now go to case number 5. Object at F or object at the focus. So let us first draw our principal axis and then our mirror. Locate the vertex, the center, and the focus, which is at the middle of the, directly at the middle of the vertex and the center. So in this case, the object is directly at the focus. So let us draw the object directly at F and do the light rays. The first light ray is a ray parallel to the principal axis. It will be reflected passing through the principal focus. Next, the next light ray is a ray passing through the center. And and reflected on the same direction. And the third light ray is not applicable since the object is directly at the focus. Okay, now, we do not see any intersection of light rays in this case. Therefore, in this case, there will be no image form because as you can see, the two light rays are parallel lines. And we know that parallel lines never intersect. Even if we extended this line in this direction or in this direction. So they will never intersect. So therefore, in case number 5, no image form. Okay, next, case number 6, and this is the last case for the concave mirror. Object is between the focus and the vertex. So again, let us start by drawing our principal axis and then our concave mirror. Locate the vertex, the center, and the focus. Again, the focus is directly at the center of the center and the vertex. And our object is here. Okay, between the F and B. So let us now do the first light ray. The first light ray is a ray parallel to the principal axis and will be reflected passing through the focus. The second light ray is a ray passing through the center and reflected in the same direction. Again, the third light ray is not applicable since the object is beyond, or the object is beyond, or the focus is beyond the object. So we cannot do the third light ray. Now, let us study this. If we are going to extend these lines, as you can see, these are not parallel lines. If we are going to extend this in this side, so they will never intersect in this side. But as you can see here, if we are going to intersect this, they will intersect on the virtual side of the mirror or behind the mirror. So remember that if we are dealing with the virtual side of the mirror, we are not using straight lines. Rather, we are using broken lines. So if we are going to extend these lines in the virtual side, so we will be using broken line to represent that this side is in virtual side, and this one also. Okay, so as you can see, they intersect in the virtual side. And whenever there's an intersection of light rays, there is an image form. Okay, so let us now describe the image, again using lost method. Location, so as you can see, it is behind the mirror. So we can write behind the mirror. The mirror. Okay. Orientation, so upright. Size, definitely it is bigger or larger. And type, since it forms behind the mirror, or it formed behind the mirror, it is a virtual image. Okay, let us summarize once again. So for case number 6, object between focus and vertex, the image is behind the mirror. It is upright, it is bigger, and virtual. Okay, let us now proceed to the images formed by a convex mirror using ray diagram. But before that, let us first recall that the spherical mirror came from a sphere. if we get a certain arc from our sphere, we will have our mirror, or our spherical or curved mirror. It has two reflecting sides. Again, this one is the concave mirror, the one that bends inward, while the one that bends outward is the convex mirror. And if we are going to recall the parts, so we have here the center of the sphere that represents the center, and this one is the primary axis, this one is the vertex, and this one is the focus. Now, since we will be dealing with convex mirror already, this side will be our reflecting side. So if this is our reflecting side, this becomes the front of our mirror, and this side becomes the back of our mirror. Okay, so definitely if this is the back of our mirror, this is our virtual side, and this is our real side. Okay, if we are going to draw that again, so we have here our principal axis. Okay, this is our convex mirror, this is our real side, this is our vertex, center, and the focus. Now, this is our virtual side, and this is our real side. Okay, since if you have noticed that the focus and the center is in the virtual side, we call this one as a virtual focus and a virtual center. Okay, let's have an example. Suppose we have an object here in front of our convex mirror. Now, let us determine the image form using the three light rays. Again, the first light ray is a ray parallel to the principal axis. And then it will be reflecting, passing through the virtual focus. Okay, since it is a virtual side, we will be using broken lines. Okay, and light ray will reflected in that direction also. Next, a ray passing through the virtual center, from the tip of the object to our virtual center, and it will be reflecting on the same direction. Okay, next, a ray passing through the focus, and then it will be reflected parallel to the principal axis. Okay, so the reflected light ray will be reflected on the virtual side using the broken line. So as you can see, the intersection of light rays occurred here. So therefore, that is our image. Okay, let us describe the image using lost method. Let us first determine the location. It is located behind the mirror. Behind the mirror. Okay, how about the orientation? Upright. Size, definitely it is smaller. And type, since it formed behind the mirror, at the back of the mirror, so it is a virtual image. Okay, let's have another example. This time, let's make our primary axis a little bit longer. Okay, let us draw our mirror here. We have our okay, first location behind the mirror. Next, orientation, upright. Size, smaller. Type, we have virtual since it formed behind the mirror. So let us compare these two examples. So as you can see, in our first example, these are the results. And if we are going to compare that with our second example, they are the same. So because unlike concave mirror that has 6 cases, for convex mirror, it has no um, it it has only one case. Okay, so regardless of the position of the object in front of a convex mirror, it forms an image which has the same description, and it is always behind the mirror, upright, smaller, and virtual.
Okay, so now that we know how to do the ray diagramming, let us again determine the application of these types of mirror. So first, for the car side mirror, as you can see here, it is being used for the driver to have a larger view of the road. Okay, dentists use dental mirror enable for them to see clearly the enlarged view of the teeth. It is actually a concave mirror. While in the car, it is actually a convex mirror. A spoon has two reflecting surface. It can be a concave or it can be a convex mirror. While for the convenience stores, for the security guard to have a larger view of the store, they are using a convex mirror. So as you can see, these types of mirror are very useful in our daily life. Okay, so in your module, you have this type of activity. You will be summarizing the description of the object or the image based on the position of the object at a certain or the position of the object. Okay, so it is also present in your module. Okay, so thank you very much for listening for today's lesson. Thanks and happy learning.